In this video, I'd like to discuss the wiring configurations used for sensors. There are two wiring configurations called sink and source. When you're wiring input and output devices, I/O, devices that are there are two wiring configurations. One is sink, or NPN. One is source, or PNP. If you remember when we did the introduction to solid-state devices, we also mentioned transistors. There are NPN transistors and there are PNP transistors, and that the terms NPN stands for sink and PNP is represented by the word source. There's actually a very easy way to remember which one is which. If you look at the words themselves, sinking or sink has an N in it, and therefore the one with two N's is sink. Usually they'll say sinking, which has two N's in it, and it comes up to NPN. If you can remember that one, the other one is source, which has to be PNP. Sink and source are terms that define the direction of current flow in the I/O devices. Sink means that the device provides a ground connection, and source means that the device provides a voltage source. That's kind of easy to remember also. A voltage source means that if the device is wired to the voltage source, the device is sourcing. And a term that was used when I first got into the field some 42 or 3 years ago, we used to be, you're going to sink the current to ground. So sinking is when the device is connected to ground. Let's look at these two very simple circuits. You see that figure 1 shows switch 1 controlling a control relay coil. And take a look at how they're wired. You have S1, one of these leads. Actually, I do want to change my pen color if I can. So that it's not red. So this is the plus side of the battery. This is the minus side of the battery, and it's grounded. So my switch, one side of this switch is wired to the plus terminal. And what we just said was that if one side of the device is wired to plus, or the power, the sourcing, that means that that device is source. So S1 is a PNP device. So it's wired source. The coil, on the other hand, one side of it is wired to ground. Since the output device, one side is wired to ground, any device that has one side wired to ground is referred to as a sink device or an NPN device. Figure 2 is a very similar circuit. Here's the plus of the power supply, the minus of the power supply, only this time, notice I changed the position of the switch. Now one side of the control relay is tied back to the plus lead of the source. Therefore, this device, having one side tied back to the voltage or the source, this device now becomes a source device or a PNP device. One side of the switch is connected to ground or common. One side of a device connected to ground makes it a sink device or an NPN device. Something you want to also remember is that when you have two devices like this, sink will always be wired to source, source will always be wired to sink. You can't have a sink to a sink or a source to a source. So why the difference? Why do I have those two differences? Well, it's all because of the solid state devices. And those solid state devices that only allow current to flow in one direction. If you think of a diode, current can only flow in one direction. So with sensors, because they're solid state devices, you're going to be told which way is the current flowing. Is it going to be connected to the source side or the power side? Or does it need to get connected to the ground side or the low side, the common side? So with mechanical switches, it doesn't really matter what direction the current is flowing. However, there is a standard for wiring switches. The National Electrical Code, the NFPA, which is National Fire Protection Agency, number 70, Article 404 of that standard states in 404.2, switch connectors, grounded conductors, that switches or circuit breakers shall not disconnect the grounded conductor of a circuit. There's an exception to that, and that exception is a switch or a circuit breaker shall be permitted to disconnect a ground circuit conductor where all circuit conductors are disconnected simultaneously, or where the device is arranged so that the grounded conductor cannot be disconnected until all the ungrounded conductors of the circuit have been disconnected. This comes out of the NFPA 2007 manual or standard. Now that's a lot for a course or for somebody that's in this course, since it's a first semester course. The thing that's important here is that the standard says that a switch should always break the hot side or the plus side, and that the load, and I'll just use a light bulb for the load, should be on the ground side or the common side. So all this article tells us is that I shall not break the ground side, I need to break the plus side. That's all that standard's telling us. That's the standard. In the sensor world, this would be a source sensor. But I can have a sink sensor and break the ground side. It all depends on the solid state devices that the manufacturer used to build the device. So why the sink and source? I think I just answered that. Sensors are solid state devices. They're electronics. They consist of diodes and transistors and integrated circuits. So when you're wiring a solid state sensor, it does matter the direction of current flow. And because of those solid state devices, it matters therefore which wire of the sensor gets connected to the power side and which side gets connected to the power source ground or common. Now, sensors are available in several different wiring configurations or connection styles. Always read the manufacturer's wire specifications before connecting a sensor. I have that in capital letters and I have it underlined. Always read the manufacturer's wiring specifications before connecting a sensor. You could actually damage the sensor by miswiring the sensor. So here are the three most common configurations. Some sensors are 4-wire sensors that can be wired as a sink sensor or a source sensor depending on which one of the 4 wires we hook up. Some of these sensors have 4 wires, but they can't be wired sink or source because one of the leads might be normally open, the other lead might be normally closed, or one of those leads is an alarm output. And we'll talk about all of these type of things as we go through this course. So again, check the manufacturer's specifications. A 3-wire sensor is purchased as being either sink or source. They can't be changed. And a 2-wire sensor can be wired in either polarity, sink or source. The 2-wire sensors are becoming very popular today. Sensor wiring vary not only between different manufacturers, but also within the same manufacturer. And again, I repeat, always read the manufacturer's wiring specifications before you connect that sensor. The color of the wire, which sometimes identifies the sensor connection type, is not really standard. So from one manufacturer to the other, or even within the same manufacturer, they may have different wire colors on one sensor and another color structure on another sensor, so there's no real standard. However, there are 2 wire colors that are most common across manufacturers, and that is the power connection and the ground or the common connection. So remember, their sensors are solid state devices, so they have to have power to operate. They need voltage to operate. So fairly common, and again, I don't want to say that this is a standard because it is not, but it's fairly common that if a sensor has a brown wire on it, that brown wire is usually plus voltage DC. Now I have listed here that it's 24 volts DC, but sensors are rated at anything between 10 volts DC to 30 volts DC. You could usually put that range on these sensors. The blue wire is usually always the volts DC common, or the ground side of the power supply. Those are the only 2 wire colors that are fairly commonly used across most sensor manufacturers. Brown for plus, blue for common. If you understand a little bit about the European color code for AC wiring, in America, the hot lead of our AC 120 volt line is black, and the neutral is white. In Europe, the hot for 100, well, theirs isn't 120 volts, theirs would be 220 or 2 something, but the hot lead is brown, and the blue lead, or the neutral lead, is blue. So they kind of follow the European standard. Again, I know you're a first semester student. You may not understand all of this stuff yet, but I want to start presenting it because you're going to hear this as you go through the curriculum. And more often than not, a lot of American companies now have European counterparts and vice versa, so that we're starting to accept a lot of the European standards, and they're starting to accept a lot of our standards. So I just wanted to mention that. So brown is normally hot or plus DC, blue is normally common or DC ground. So let's look at some sensor wiring diagrams, and there's no standard for drawing these. You go to a sensor catalog and they'll show you the wiring diagrams, and every manufacturer has a little bit different way of showing things. They show the exact same thing, but pictorially it's a little different. If we take a look at this very first one, this is an NPN sensor. It's syncing. Here is the sensor itself, and it's shown as a limit switch. This happens to be a 3-wire sensor. Note, the blue lead goes to negative, or the common, which is ground. Note the brown lead goes to plus, which is the plus volts DC. So this is how the sensor gets its power. Also notice that one side of the switch is connected to ground. That's what makes it a syncing sensor. Now the load. That load could be a relay coil, that could be a light bulb, it could be a PLC input. The load therefore has to be source. If you remember from that little switch diagram, one side of the source gets tied to plus. The other side will go to the switch, and this one uses a black lead. So this wiring diagram, by looking at the wiring diagram, if you didn't have this up here, you would be able to look at this and say, look, at one side of this switch is going to common, so this must be a sync sensor. And therefore the load that it's switching has to be source, and one side has to go to plus. The PNP sensor, take notice, the brown lead now goes to plus. This is plus volts DC. And the blue lead goes to negative. So it's the same. The brown went to positive, the blue went to negative on the syncing. Here the brown went to positive, the blue went to negative. That's the same, but internally the brown lead is now connected to the switch. That makes the sensor, because it's tied to the power, a source sensor, or PNP. The load in that case then has to be sync. One side of a sync device goes to common, which it does, or ground. And the other side goes to this switch, and it's the black wire of the sensor. Here's another diagram. This one's of a 2-wire sensor. So this one's showing you the connector, and this is a 4-pin miniature mini DIN connector. They're called a DIN connector. You'll take notice that there's only 2 wires on it. Here's the switch, and the load is out here. And this is blue and brown. I can change the polarity of this simply by reversing the polarity on this side, and that's why this says plus and minus, plus or minus, plus or minus. Here's yet another one. This is a 4-wire sensor. Look at the commonality. The blue lead goes to the common, or the ground. One side of this switch goes to the ground, so this is a syncing sensor. The brown lead goes to plus. This is plus volts DC. This one has a normally open and a normally closed contact. The normally open contact is black. That's the black lead. The normally closed contact is the white lead, and they're saying it could be gray also. So this is a syncing sensor. That means the load has to be source. These loads have to be source. And they are. One side goes to plus. Here's the same sensor. Here the brown lead's still going to plus. the blue lead is still going to minus, but now the plus lead is going to the device. So that means this is a source sensor. One lead of the device goes to plus. The blue lead's still going to common. That means if this device is source, the load here has to be sync. And if it's sync, one side goes to common. This also has a normally open and a normally closed, where the black lead is the normally open and the white lead or the gray lead is normally closed. So by the sensor diagrams, you can tell what polarity the sensor is. Here's another drawing of a 4-wire sensor. The same things hold true here. So nothing's really changing. Look at the brown lead. This one's just showing the mini DIN and its pin out. So the brown lead's going to plus. The common of the switch, the pole, is going to common, which is the blue lead. That makes this a sync sensor, which means the loads have to be source, which means they get tied to plus. This is plus volts DC. Here the normally closed contact is white. The normally open contact is black. Same sensor but in a different polarity. The brown lead now goes to the pole of the switch, which is going to plus volts DC. Plus volts DC to the device makes it a source device. If this is a source device, the loads have to be sync. They're sync, they get tied to ground, which they do. The blue lead also gets tied to ground, as it usually does. The normally closed is white. The normally open is black. Here's a diagram of a 4-wire sensor by a different manufacturer. And in this manufacturer, this 4-wire sensor can be wired as either sync or source. Here's the way they're showing their switch contacts. Note, the brown lead here is going to plus. The plus is going to this switch. If the plus is going to the switch, this switch is source, which means that the load that it's controlling has to be sync. So this is sync, and it sure is because it's tied to the ground, and that happens to be the black lead. This switch, the pole, is going to ground. It's the blue lead. The switch is going to ground, so this switch is sync, which means the load has to be source. And it is. One side goes to plus. The white lead is connected if I want a sync sensor. I tell people an easy way to remember when it's a 4-wire connection and it can be sync or source, an easy way to remember which lead it is, and again, this is not a standard, but it's fairly typical if it's can be wired as either sync or source, is that years ago, bathroom sinks or kitchen sinks were available in one color, and that's white. White porcelain. So if you can remember that, you know what, bathroom fixtures were white porcelain, your bathroom sink was white. So that's kind of how I remember that the white lead is usually the sink connection. So the white lead is usually, and I don't know if there's a symbol for that, usually a sync connection. And that way the other one, the black lead, is usually the source connection. But again, check the manufacturer's specification sheets. This is another type of diagram, and it's the last one that we'll look at here. And this one is from a manufacturer called Keyence. Take a look at the way they specify their sensor. Here they have a brown lead, which is going to, either plus or minus. They have a blue lead, which is going to minus or plus over here. They also have a black lead and an orange lead. The black lead is actually the control output. That's the switch part of it. And it's going to a power supply. The orange lead is an alarm. Some sensors have an alarm in them so that if the gain setting varies or something happens at the sensor, it'll turn an output of the sensor on to send to the controller, just to let you know that something's going on. The pink lead in this one, if it's tied to this side plus, it is light off or dark operated mode, and if it's tied to this side, it's light operated mode. So this one, light and dark modes have a wiring configuration. The PNP side of this guy, this was the NPN side, the blue lead goes to common. And this is actually a typo. This should be the black lead. I actually redrew these. The black lead is going to plus. I'm sorry, boy, I'm making mistakes here. The brown lead is going to plus. The black lead is the control lead to the load. Here, a purple lead is used for output mode control. And you'd have to read the manufacturer's manual to know what that means. And then the pink lead in this case is used to know whether it is dark mode or light mode. So that's another way of identifying sensors. So that's about all we're going to talk about online here about sensors and sensor wiring. You're going to have some experience wiring sensors because we'll be wiring these sensors for the rest of the semester and in several different configurations. So I hope this helped, and I'll see you in class.